Okay, so we're looking at scale for scale diagrams, often maps or diagrams of larger objects. Sometimes it can be the opposite, a really small object. So like in your science textbook, maybe there's a picture of a cell or an insect or something really tiny, but it's bigger than real life on your book, in your book. So that's, we'll have to have a scale on it so you know that how to calculate the dimensions. So just a reminder about similar polygons. So here, these are all triangles. It says, how are the small and large triangles related to ABC? So triangle ABC is the middle one, and you'll notice this is A prime. It's got a little dash on that, and this is A double prime. So that just means it's an image or another object that's related in some manner. So if you take a look, angle A is 55, A prime is 55, A double prime is 55 as well. And 70, 70, 70, 55, 55, 55. So these are all have, so corresponding angles. Corresponding angles are equal. So we're not saying 55 here and 55 up top, but it could be rotated. But in any case, these triangles have 70 and two 55s. Then if you take a look at the sides, so this side here, 1.5 to 3, well, that's twice that. And then 3 to 4.5, that's 1.5, right? So does that work the same on the other sides? Check. Well, 1.5 to 3. These are all isosceles triangles, actually. So you just want to check. 1 times 2 is 2. Yep, that works. And then 2 times 1.5 is 3. Yep, that works. So sides are proportional. So we call these similar triangles. That's a math terminology. Similar sometimes in real life just means they're kind of the same, right? They look, when you talk about two people, oh, they look similar. Well, they have some properties the same. Well, these have certain properties that are the same. The angles have to be the same, and the sides have to be proportional. So it says Jeb drives a truck. He often needs to read a map. His map of British Columbia shows a scale of 1 to 10 kilometers. Now I know we often use Google Maps in our cell phone, but sometimes you have to know this, right? So what is the scale ratio on the map? So often a ratio of a scale is given in colon form, but the biggest thing is it has to be in the same units. So if you see a scale that's something to something, you'll never see units with it. So they have to be the same units, because you could be measuring with a metric ruler or an imperial ruler. So it's just a ratio. But so we're not going, if you see something like 1 centimeter to 10 kilometers, then yeah, it has to have the units on it. So, so here, what is the scale ratio of this map? So we need to figure out what 10 kilometers is in centimeters. Okay, well, 10 kilometers, remember there's 1,000 meters in a kilometer and 100 centimeters in a meter. So really there's 100,000 centimeters in a kilometer. So times that by 100,000 gives you 1,000,000. So the scale ratio is 1 to 1,000,000. So what scale factor must Jeb use to convert a distance on the map to the actual distance? 1 centimeter on the map equals 1,000,000 centimeters on land. So we must multiply distances on the map by a scale factor of 1,000,000. So the distance between Calgary and Medicine Hat on the map is 27 centimeters. What is the actual distance in kilometers? So we need to multiply by 1 million. So that's going to be 27 million centimeters, which is kind of meaningless because centimeters are so small. But then we want to convert that back to kilometers. Okay, so we'll take the 27 million centimeters. And remember, 1 kilometer was 100,000 centimeters. So then we're going to divide by 100,000 because 1 kilometer is 100,000 centimeters. So that's 5 decimal places. You can use your calculator or you can move the decimal 5 to the left. So it's 270 kilometers. Okay, biggest thing to remember over here, if the scale ratio is 1 to x, then the scale factor is x. As long as that first one is a 1, then the second number will be your scale factor. Okay, and always try to show like a scale will not have decimals or fractions in it. So you always want to reduce it to lowest terms, but no fractions or decimals. And if you can get it down to a 1, then that's awesome. Makes it easier. Okay, architects draw scale drawings of homes. A common scale is 1/4 of an inch, represents 1 foot in real life. The height, length, and width of a home are 6.5 by 6.5 by 10 inches on the drawing. What are the actual measurements? Okay, so what's the scale ratio on the drawing? So again, these are in different units, but they're both imperial. So 1/4 of an inch, okay, to 1 foot. Well, remember how many inches is in a foot? There are, so we need to convert this feet to inches. That's 12 inches in a foot, okay? And so then we're going to multiply both by 4. So we're just copying that out underneath. Multiply both by 4 because we don't want a fraction in our, like we showed this now as a scale. That's still not in proper form because there's a fraction there. So we want to multiply both by 4 to get 1 to 48. So now we typically show it a scale in colon form. Okay, so that means the scale factor is 48. So that means we're going to multiply each dimension by 48. So you can get out your calculator. 48 times 6.5 is 312. That'll be 312. 48 times 10 is obviously 480. And then we want to convert it to feet. So then we're going to go back, take 312, and remember that there's 12 inches in a foot. So you can multiply by 1 over 12 or just divide by 12. So that'll be the same here. And then it'll be 480 divided by 12. So you might know back from here, 12 goes into 48 4 times. So, and then you can multiply by 6.5, multiply by 10. So, but if you're not sure, use your calculator. Okay, so we'll take 312, okay, and then divide by 12 to get 26. So 26 feet, 26 feet, and then this will be 40 feet because 12 goes into 48 4 times with a 0. Okay, so the height is 26, the length is 26 feet, and the width is 40 feet. All right, Noreen collects model toy cars. Many of her cars are built using a scale of 1 to 64. A model of a 1966 convertible is 9.8 centimeters long and 3.5 centimeters wide. What does the scale mean? What are the dimensions of the actual car? So the scale means 1 unit of measure on the model. So this is always the model or the map. And the second number is real life. 64 units on the actual car. So actual dimensions of the car are 64 times the dimensions of the model. So what is the length of the car? So we would take 64 multiplied by 9.8, take 64 multiplied by 3.5. So let's do those. $627.2. In meters, we would move 2 decimals, so 6.272. So about 6.3 meters if we go to 1 decimal place. And then 64 times 3.5, 224, which is 2.24 meters, so about 2.2 meters. And then, oh, I guess we didn't have to do, did I miss something? The length and the width. Just let me check. No, it didn't ask for the actual, didn't ask for the other dimension, which was the, oh, I guess that's all it gave, right? The length and the width. It didn't give the height of the car. So I was thinking that maybe it did. Anyway, that's the end of 7.5. So you can work on the practice for that. And then go on to 7.6.